In this video, we are going to solve the inequality, the absolute value inequality, absolute value of 2x plus 6 is greater than 7. All right, so the inequality that we're trying to solve is the absolute value of 2x plus 6 is greater than 7. So what we want to do is set the interior of that absolute value equal to 0. When we do that, we end up with x equaling -3. So what we're going to do, we're going to build a number line, which is helpful for organizing our solution. And we're going to indicate the value x equals -3. And we're going to build a wall there. I like to think of it as a wall. It's going to act as a mathematical restriction. Now, to the left of x equals -3, 2x plus 6 is always going to be less than 0. If you don't believe me, think of a number like -4. 2 times -4 plus 6 is definitely less than 0. That means the absolute value of 2x plus 6 will be negative of, round bracket, 2x plus 6. And that's the same as -2x minus 6. Okay? So for me to solve 2x plus 6 is greater than 7 when I'm to the left of -3 would be the same as solving -2x minus 6 is greater than 7. Well, that's like saying -2x is greater than 13. Dividing both sides by -2 would give us x is less than 13 over -2, which is -13 halves. Now I ask myself, is -13 halves a number in this interval? And the answer is yes. -13 halves might be right about here on a number line. So what I want to do is I want to shade in all values of x that are less than -13 halves that also meet the restriction of x having to be less than -3. Another more colloquial way of saying that would be shade in everything in this interval to the left of -13 over 2. Well, in other words, what I'm going to do is I'm going to shade in x less than -13 over 2 because all values of x less than -13 over 2 are in this interval. Now let's flip over to the other side. On the other side, 2x plus 6 is greater than 0. What that means is the absolute value of 2x plus 6 will simply equal 2x plus 6. So solving the inequality 2x absolute value of 2x plus 6 greater than 7 will be the same as simply solving 2x plus 6 is greater than 7, which means 2x is greater than 1, which means x is greater than a half. So now what I want to do is shade in all values of x that are greater than 1/2 that also meet the condition of x being greater than -3. In other words, shade in all values of x greater than a half, because they're all on this, they're all in this interval, all on this side of the wall, so to speak. There we go. So now I've got my answer. I've used that number line up top to organize my solution. Right there, that whole number line is what I'm going to now put in my solution set. But what I need to maybe do is just check at x equals -3 if that's a valid solution. So if I want, I can plug in -3, 2 times -3 plus 6 being greater than 7 would imply that -6 plus 6 absolute value is greater than 7. Well, -6 plus 6 is 0. The absolute value of 0 is 0. Now, is 0 greater than 7? Absolutely not. So we're not going to include an x value of -3 in our solution set. So our solution set is going to be the set of all x element of the reals such that x is less than -13 over 2, x is greater than 1 over 2. If we wanted to state that in interval notation, which was asked for in the question, we could say in the interval from -infinity to -13 over 2 in union with, I should look more like a U there, in union with the interval from 1/2 to infinity. All right, hopefully you enjoyed that, got something out of it. I sure did. And we'll stop recording.